So moving along with our morning session, our next speaker is Dr. Alain Moreau. He is the newest member of the Open Medicine Foundation's Scientific Advisory Board, as we heard this morning. Alain is a full professor in the Faculty of Dentistry and Biochemistry and Molecular Medicine Department at the University of Montreal. And we're very much looking forward to hearing what he has to say. Ron.
I got to know him because of the work on MECFS and realized he was doing a lot of unique things and a lot of things that we were not doing but needed to be done. So it was a perfect example of pulling some people together. We can't do everything. It's ridiculous. And getting a team effort to do this and working together. And it was clear that he was a good collaborator, had a lot of novel ideas. And so he's been brought in. And now he's part of the Scientific Advisory Board, and I'm glad to have him. And it's great to get other countries involved. And Canada's a great country. Thank you.
Thank you very much, Ron. It's a great pleasure and privilege to be with you again for the third year. Before I'm talking about you and me, let's talk a bit about me. I hope you are not too confused. I'm Canadian. In fact, I'm French-Canadian. So this is where we are. So you may recognize my accent, so I apologize for that. But the most important thing is I'm a proud father of a 1-week new baby. Stop it. Okay. This is a fake news. I'm a proud father of a 1-week-old baby called I Can't See Me, which is our national research network funded recently by the Canadian Institute of Health Research. It's funny because you have the same reaction that my colleagues when I announce that, say, wow, a new baby! And suddenly, oh, this is our national research network. It's a bit more boring, but for us, it's a very important step in the development of research in Canada, increasing our capacity and talent development. So, as I said, you can always count on us. Maybe not about basketball, so sorry, Warriors. And also, one of our friendly neighbors asked me to pass a message, is there a beautiful island or not for sale? Here my disclosure. So let's talk about you and me. So what are the actual current challenges? And Dr. Hansen also evoked that about the clinical heterogeneity of the disease. How can we integrate those multi-omic data? So already clinically speaking, the disease is very heterogeneous. And now we are generating data with very sophisticated technologies that will multiply the data and the complexity. So how can we start to talk to each other? So I would try to show you different ways and what we have done so far. So one key question that Ron always pushes us is about how can we develop a molecular diagnostic test for ME. So I would say we need to choose wisely. We need to work together first, but also to decide what are the real objective behind such a development. What are we looking for, really? So they have some methodology issues, and I will talk about the need to do provoke studies or using a stress test. And from that, we will also present you some data about the microRNA profile. How can we use to further define or subgroup patients to understand the cause of some symptoms. And also, I will give you a pretty good example about the possible origin of brain fog, who is vulnerable and why. I will talk also a bit new data about identical twins, and I think some of you that already participate, and we're still looking for identical twins with ME, especially concordant twins and discordant twins. So if you have a twin, a brother or twin sister that is suffering of ME or healthy, please let me know. I would be very happy to work with you. and some new hope about how can we develop possible treatment. So you already know that the elephant in the room is me. This is a new cartoon, so I would say we are quite less blind. So I always use this allegory of the elephant in the room not to tell you that we are blind, but we are covering the whole elephant. Of course, we have favorite parts, and knowing that, we really right now knowing that there are more than one elephant in the room. So we are dealing with a group of elephants because patients are very heterogeneous. So we need to understand that before to allow us to move forward. As I told you, with the multiplicity of the new technology called the famous omics, you can look at the genome, you can look at the metabolome, proteome. So at the end of the day, everything is finishing by ohm. And we are generating a lot of data. And those data, eventually we need to develop a kind of converging vision to develop some molecular signatures that will help us to have a diagnostic and eventually even a prognostic test to address who can respond to this type of drugs and who wouldn't, and to tackle the different key symptoms of the disease. So that will lead us to a great comprehensive understanding of the disease, which is great, and it is necessary, but also we need to find in this big noise of big data, what are the possible actionable therapeutic targets? Is it something that, say, it's elevated? We know it's associated with the disease, but we cannot change it. Or it's something that is elevated, but I can find a drug that can reduce it, and we can prove if we reduce it, we improve the symptom, and for some of them, we may even one day cure the disease. But we need you. Strong partnership with patient is the key. There is no way that researcher and clinician can be successful in this very, very difficult task. Why we need you? Because you are the expert of your disease. You know much, each of you, you know much, not only about yourself, but about the disease. And we need to work with you to gain such information. So this is truly a partnership. So patients are not simply a clinical study participant, but is a true partner. This is something that I truly believe, and this is why in our national network, I Can't See Me, patients are true member, equal member than researcher and clinicians. Very important for us. So let's talk about provocation study. So I don't want to provoke you, but first question, do you need a stress test? And why is not sampled? Oh, by the way, those are not typical Canadian fellows. We are a large country. We have a lot of diversity. I don't know why I picked those, but I thought that was appropriate for today. And by the way, Winzong, be aware that we have much larger beasts in Canada, so maybe your car could be in a very dangerous situation, okay, with beaver. So we did some essay to develop a stress test. Maybe that's not the best. I should call it the PEM test. Some of my colleagues at Stanford call it the squeeze test. We will figure out something one day, but the most important thing is because the patient came to us with a different history. Some have a short illness duration, others have a very long illness duration. Some patients are taking up to 9 different medications. So how can I work with this diversity and very heterogeneous group of patients? The solution that we develop, and that will be being done by one patient that helped us, Christian, I'm sure he's watching right now, is to reproduce in a safe manner, if we can say, post-exertional malaise. And today we develop a machine that apply a gentle therapeutic massage. Normally it's a therapeutic massage on LT people, but on ME/CFS patients that create post-exertional malaise. And today we are also with the support of the company called Exoskin, using their health sensor and smart vest, we are able to register different physiological parameters at the same time that we, before and during the test, and also for a certain period of days after the test, to really monitor post-exertional malaise effects. So we are taking a blood sample before the test to have baseline value, and after 90 minutes of stimulation, so that's allowed that each participant being his own control. So that's why we can test all patients. Secondly, this is a portable machine. So 85% of patients that we are testing are at least housebound. So we are sending nurse toward them to make sure that we can test them. This is a big difference because for the very first time, we are testing very sick people that normally are not participating in clinical trial. So this is an example. We use twin. Identical twin, but discordant for the disease. So you see in orange the value of the heart rate for the affected twin with ME, and in blue the LT co-twin. So you see on the upper panel the heart rate before the stress test and also after the stress test. And we also, thanks to Exoskin algorithm, we were able also to monitor some sleep data. So in the table 1, you have the value for the healthy twin, and table 2 is the MECFS twin. And you can right away see before the test, there's more sleep position change twice in the affected twin. And we also see the REM sleep, rapid high movement sleep, is twice, which is known in the literature. What is very intriguing is following the stress test, so after post-exertional malaise, we saw a dramatic reduction in the REM sleep where you are taking your energy, okay? So this is kind of system is affecting that. So those are very preliminary results. We need to further explore and assess if we can see that on all patients or on only some subgroup. But for us, it was the very first demonstration and feasibility of using the Exoskin with the stress test that really create post-exertional malaise. I told you that we have to deal with different elephants. So this is 5 subgroups that I proposed you last year. I don't want to go in more detail about that because I already covered that, and you can go on YouTube and you will see more explanation about each of those microRNA. But that match, you can see the difference in terms of the post-exertional malaise symptom following the application of the stress test. So that allowed us to stratify the patient for the first time and look for the possible mechanism and cause that can be underlying those symptoms. So for instance, using the classical questionnaire, you can see, I will just give you a few examples, that the subgroup 1 is the one showing the less daily activity. So suggesting they are more affected amongst the affected patients. So it's the same thing for the MEF20 for mental fatigue. So there's a big difference on the group 5. So it seems to be more affected and so on. Thanks to Dr. Davis' inspiration, I would say, we also look to try to further define or characterize what was different between these 5 subgroups based on our microRNA stratification. And this is where we use the plasma and a technology called cellular dielectric spectroscopy. In a simpler term is bioimpedance. So this is an electric machine. So you can see that the machine, there's some small electrode at the bottom of the well, and when you see the cells, when the cells are stimulated, normally by a plasma, a ligand, an hormone, there's a small reorganization of the cytoskeleton that would change the electric current around the cells and inside the cells, and that would modify their resistance. This is exactly what we are measuring in real time during about 10 minutes. So what you can see in the bottom panel in black and white is if we use a Jurkat cells, which is a well-known cell line of human T cell immortalized, we apply different concentration of LT plasma from control. You don't see a significant increase in the bioimpedance. But if we apply a different dose and concentration of ME/CFS plasma, you see a strong rise in the bioimpedance. And we use another disease control from patients suffering of scoliosis. And we saw no phenomenon. So there is something very specific in the plasma of the patients, exactly as Dr. Davis has shown recently by a similar technology that is associated with the disease. And we look on the color panel at the bottom that by applying the same approach with representative sample of each subgroup, we find out that we have a different response. So the black slope is from control, and the 5 in colors are from the 5 subgroup. So that once again indirectly showed that we are dealing with some different elephants, well, different subgroup if you prefer. Now, using this technology, we can screen for different response toward different receptors. So again, this is a further proof of concept. If you look at the B panel, C and D panel, that by using different ligands that are activating, for instance, in the B panel, the MNDA receptor, and we compare control in the 5 subgroup, we have a differential response. So again, the elephants are different. So this is very important because if we use this approach to screen for drugs, we should expect that some drug may have some impact on all of them or on only some of them. So this is a very powerful tool for eventual development or screening of potential therapeutic drug. Knowing that these 5 subgroups have a different symptoms, we explore that to try to figure out the origin of the brain fog. Very ambitious task, but something important for you. So you see on the subgroup 5, this is the only one that report after the stress test. So we induce the stress test. This is the one that report brain fog symptoms, so like mental fogginess, vertigo, dizziness. So we decide to assess different effectors that could explain those symptoms in this subgroup in particular. So we did some biochemical measurement, and we find out a molecule called thrombospondin-1, or TSP1. So again, it's the same principle. If the brain fog occurs after the application of the stress test, I should see a difference at the end of the stimulation. So that's why we measure a delta measurement, so the value after the stimulation minus what was the value at the starting point at the baseline. And this is what you see here. So on the panel A, you see the variation in the concentration or delta concentration of the thrombospondin-1 or TSP1, and you can see the highest elevation after the stress test is exactly in the subgroup number 5. And this is very exciting for 2 reasons. Thrombospondin-1 is an anti-angiogenic factor. It's vasoconstrict. It reduces the size of small vessels and probably at this concentration, even much bigger vessel, blood vessel. So if you are fainting, developing a kind of brain fog, it's probably that your brain blood flow is reduced somehow. And this is probably one molecule that could explain that. This molecule is also known, if you do mouse model, this molecule is also known to increase exercise capacity. So, but the reversal could be true. If you have too much of thrombospondin, you may have some reduction in your exercise capacity. So this is very interesting. And we also look at the panel B thrombospondin response. Also very interesting, thrombospondin signaling through membranous receptor like CD36 and CD47 could explain the observation from Dr. Davis' group about the red blood cell deformity changes in ME/CFS. So I think we are really going in kind of convergence of the group, and this is the very much added value of this working group organized by Dr. Davis and by Open Medicine Foundation. So, are we closer to our pharmacological treatment for ME/CFS? We try our best, for sure, so this is the only guarantee that I can give you. And of course, we try a molecule called Thymoquinone because this is a powerful immunomodulatory molecule, anti-inflammatory molecule, anti-cancer molecule, is doing a lot of things, and this molecule is naturally present in the black seed of a plant called Nigella sativa. So do not try Thymoquinone pure or to inject it. This is a very first preliminary result, and looking at the result is very promising because it's decreased significantly the bioimpedance, but we don't know yet what exactly we are measuring. So we need to have a more comprehensive view about the mechanism to do that, and you can see that the group 5 is the one that has less efficacy here. So again, that won't be a magic bullet to treat ME/CFS, but this is just to show you that we are developing the right tools to address and look for potential therapeutic molecule by knowing a more specific approach to do that. Let's talk about twins, okay, because I think working with identical twin is very important. So far we have 7 identical twin pairs discordant for ME/CFS, so that explains the red and black color. So if you are suffering of, you are colorblind, maybe they appear to you in gray or green. I apologize for that. And we have also concordant twins. So we look for the twins using the saliva about change in the DNA methylation profile. And DNA methylation profile can lead us to some different patterns. So again, just by chance, maybe, we end up with 5 subgroups. It's unlikely that these subgroups will perfectly match the previous 5 subgroups using microRNA, but by chance, we end up with 5 subgroups. And those subgroups also involve genes that are necessary to fight viral and bacterial infection. And one of them, called SLC1A2, is also hypermethylated. So when we say hypermethylated, this gene is downregulated, is less expressed in many cells. So this is an example on 3 set out of 4 of twins, and can be linked to the accumulation of glutamate in the brain and other part. And also that we know that glutamate level could be also linked to the exercise-induced fatigue. So very interesting and powerful tool to address that. So let's talk about you and me. I think it's time to shift from confusion to clarity. And this is not that simple because you are very heterogeneous, 5 subgroup of elephant, multi-omic data, big data. So if I'm telling you, oh, I'm afraid you are suffering from an increase of MYR486, and you have an aberrant methylation profile, and by the way, your TSP1 is elevated, you have no clue what I'm talking. Think about the physician that will tell you in his office. So we need to translate that in something useful. This is what I'm referring to, a shift from confusion to clarity. And that phrase I took from Janet because that was a comment from one of ME/CFS patients. And I think it's very inspiring. So I think we are in a hot pursuit for a diagnostic test and looking for therapeutic option more than ever. We are in the way to stratify patients and get more insight about the cause of the key symptom. We can already predict whether or not some patient can respond to rituximab or Amplygene, whatever we think that can be a solution or a temporary solution. And eventually, having a better knowledge of what is causing some specific symptom like brain fog, we can act by blocking TSP1 signaling and also using other drugs known or Thymoquinone to reposition them to improve key symptoms. So in conclusion, I would like to acknowledge all the participants, ME/CFS patients and their family for their insight and participation, as well as the different funding organizations, including CHR and the Civil ISA Foundation, and also patient organization and patients for their contribution, because without you, we cannot be successful. And I truly believe in collaboration research is the key. Thank you.